It's called quality assurance process, or popularly we call it as testing. So, okay. So what is testing? Okay. So there are two important definitions. Okay. So first, Mayer said that testing is the process of executing a program, okay, with the intention of finding errors. Okay. The intention itself for the tester is to find errors, right? And second point, which we need to understand, it says testing can show the presence of bugs, but never their absence. So when you test it and you find some error, that means error is there, right? If you find some error, okay, that means error is there, definitely. But if you don't find error, that doesn't mean that error is not there, right? It's just because we could not find it doesn't mean that there's no error, correct? So we have to have that mindset. We need to understand that when you don't find error, it doesn't mean that error is not there. Okay. Okay. So I'll ask you one more thing. So let's say you have, you're working on two different projects. Okay. In one project, on day one, let's say you found 50 errors. Okay. In project A, you found 50 errors on day one. Okay. And on the second project, okay, which you are working, maybe a different time, okay, you found only 5 errors on day one. So one project you found 50 errors, second project you found 5 errors. Now, which project, A or B, will have more errors on day two? So on second day, okay, what is the kind of error that you are, how many errors are you expecting with project A and B? Then what do you think?
Maybe in project A, they may try to reduce the errors. In project B, sometimes if they are solving some problems, maybe they'll get more bugs, because if in one place.
It means, the project A, since you found more bugs, that means the project A is not done properly. Okay.
It's not
successful. So you will find more bugs. Okay. Probably in day two also you'll find around 50 bugs. Okay. It means that project A has not been done properly. Okay.
Yeah.
See, when you read somebody's essay, let's say, if the first page is not good, right? Second page also you'll find it not good. All right. It's not that, okay, first page is bad, second page will be good. If first page is good, second page will be bad. No. So when you read the essay, and if if you are impressed by the way the essay has started, more likely that person has ended the essay on good note only. All right. Same thing with product. So if the team has done a great job, on day two also you'll find less bugs only, and you are expected to find only 5 bugs. Okay. Project A, okay, has not been done good. People have not, given enough attention, or they have not done well. Okay. So on second day also you will be expected to find more bugs. Okay. So, that's what, okay. So it's about the quality, right? So Sachin, when it goes to batting, right, we always expected him to score high runs, right? Because he's one of the greatest batsmen, right? So of course he can get out on duck as well, but every time you expect him to score well. Same thing. The product is good. Every time you expect it to give you less bug. The product is bad. Every time you expect to give it more errors. Okay. Levels of testing. Okay. So there are different levels of testing. Okay. And as the name suggests, levels, they are done at different time. Okay. So same code or same product would undergo all this testing at different point of time. The first is called unit testing. Okay, so in development environment, you will have a developer, okay, or group of developers working on their piece of code, right? In agile world, they might work only for 15 days or 10 days or 20 days, right? Or a month. So unit testing is the responsibility of the developers to test their own code. So whatever, like say if I've written a logic to add two numbers, I will test it to make sure that it's working fine. Okay, that's why it's called unit testing. Unit testing is the responsibility of software developers. Okay, so here they test their own code. Okay, they test their own code. Okay, the next is integration testing. So when they are done, okay, all the developers are done. Okay, so let's say you had a the cycle of 15 days. So after 15 days, or you will integrate all that code. So everybody's code, you'll put it together, okay, and then you will test it. So of course there will be testing team which is responsible to do that, and there will be some predefined tests that you will run. This is to make sure that integration has happened correctly. Okay, so integration means you are integrating the code from different developers and combining it and making it as one product. Okay, that's called integration testing. Then you have validation testing. Okay, validation testing is that once it's integrated, it goes to the dedicated QA team. Okay, that every company will have dedicated QA team, quality assurance team. Somebody would call them a verification validation team. Okay, so their job is to make sure, okay, that the product is working fine. So one of the most important, okay, and this is the testing that you will hear a lot, is called regression testing. In regression testing, okay, same feature, same workflow. Okay, so that's where, so here, so whatever use case that you will write, that use case is tested here. So this is a direct linkage between QA and BA. They will take exactly your use case, and whatever you will mention, they will test it. Okay, and if it performs as per your expectation, as per your BA document, they will pass. Otherwise, they will say there's an error, but the development team will have to fix it. So regression testing, okay, is about testing a particular feature with all the possible values. Okay, so we'll talk about it in the next slide. What are different possible, when I say different possible values, what are different possible values, like boundary conditions, negative conditions, because the intention is to find errors, right? So the simple, like if we are implementing a simple addition of two numbers as a project, right? So of course, first you will type 2 and 3. So that's the simple use case. But your intention is to test whether it's working fine or not, right? So you will give difficult values to test, right? Maybe you'll give -3, -6, -5, 0, to make sure that it's working fine even in those conditions, 0 and minus conditions. That's why we call it as regression testing. You are not just trying to pass the test, but you're trying to find mistakes or errors. Okay, so that's called regression testing. So unit testing, integration testing, validation testing, okay, is about making sure that the product is working as per the expectation. Validate. What do you validate? You validate the system with the BA requirements or the use case requirement. Okay, so you validate whether your product is working as per the use case or not. Okay.
Thank you, sir.
Okay, so now you have alpha testing, alpha and beta testing. Alpha and beta, okay, it's generally it is like when your system is ready, okay, and it is ready to be deployed. Okay, so regression testing, it's done and you are ready to deploy. Okay, let's say the product is new, okay, and you're not sure whether Okay, see, if you are developing it multiple times, right? You're adding a new feature to it, it's fine. But when you added a lot of features, or first time you're into market, or you have made many changes, you want to play safe in a sense. Okay, that it's possible that your product can have many bugs. Now, if you release it, if you give to customer and customer finds bug, right? You will, you'll have problem, right? Customer, might even cancel your product, right? So what they do is when you have lot of features or a lot of new things that you have added, okay, so they will take this alpha beta testing route. Alpha testing is the regression testing is dedicated by your QA team. Alpha testing, you'll set up a lab and you'll invite people from your company, from your team to come and test it. Anybody, sales, marketing, development, anybody can come and test it. Okay. Sometimes, in our old company, we used to call it as monkey testing. Okay. Monkey testing means what? You are giving your system to monkey to test basically. Right? That means they can hit any key. Okay. If you want to add two numbers, you'll give A plus B. So you're not resting. You're asking them to test and use it anyway. Because see, your system should be good enough to catch such mistakes. It should not crash, right? So you'll have so you will have these people come and test your application. Okay, and alpha testing is done within the organization, outside QA team, of course, but within the org, right? People from any department, can come and test it. Beta testing is next level where you are releasing it to the public. You are saying that, dear users, this is beta testing. That means this is not the real product. Okay, you can come use. Okay, sometimes these gaming companies will do a lot, right? So let's say they have version 10 in the market, so they launch a version 11. Okay, as a beta testing. As a beta tester, okay, one is to create the buzz. Okay, people start talking, oh, the new version has these features, that features. It is to create buzz and also, to get feedback from your regular users. They'll say, oh, this feature is not good, this is giving a lot of problem, or this is not great, right? So that you can go back and change it. So beta testing is really releasing it to the public, but it's not a full version, okay? You will call it as beta, okay? So that they know they cannot claim it, okay? They cannot sue you, since, something goes wrong, right? So if beta testing is meant only for testing, not for real application or what you call that deployment or, the production environment. It is supposed to be worked and tested, okay? So for the user, there's a benefit, okay? You are getting to use a product before it is released, and most likely these are available for free of cost, okay? Because we don't charge any money for beta testing, okay? But they can limit, they can tell you that, okay, we'll release only to our top customer, or we'll release to only 100 customers, 1,000 customers, right? That kind of restriction might be there, but you don't have to pay. So you're getting to use a product, okay, understand the features, okay, and then when they release it, you have a choice whether to buy or not, right? So sometimes companies will give discount to the beta testers, right? If you have tested the product in a beta test, they might give you some discount and things like that. So beta testing, okay, is in testing phase itself, okay? So that's why you cannot use it in the production development, but you use it to see what are the features, okay, how is that being used, okay, what are the new features that are going to add, right? So that's what we call it as beta testing. Alpha testing is same purpose, but it is internal, for open to only employees. Beta testing is available to worldwide customer, okay? So these are different types of testing. Acceptance testing, right? What is acceptance testing? So acceptance testing will mostly be done by your customer, right? So before they accept your solution, right? So so they'll do the important test, and if they like, I mean, if there is no concern, they will accept. Okay, and then you'll go and deploy it. So this is done before the deployment stage to make sure that customer likes it. Okay, so these are different types of testing: unit testing, integration testing, validation testing. So in validation testing, you'll hear about regression testing, alpha testing, beta testing, and acceptance testing. Purpose is different. Okay, the people who will be doing these are different. Okay, but mostly when you talk about QA team, they would do the regression testing. Okay, generally testing means regression testing. Okay, other testing you have to use like unit testing, integration testing. You have to use both the name. But when you say testing, by default it means the regression testing. Yes. Okay. So in unit testing, we test the logic, the algorithm. Has it been built correctly or not? Okay. Interfaces, independent paths. Okay. So what does that mean? Again, if you have done coding, you'll understand it easily. See, when you write set of lines of code, you will not, always execute same lines of code. For example, if you are creating a simple program to give grades, let's say it's a school management software, you enter the marks and the software will automatically calculate grade, let's say. So grade, you can have 7 grades, let's say A, B, C, D, E, F, okay, or 5 or 6, whatever, right? Now, for every student, when you enter the marks, one of the grade will be displayed, not all the grades, isn't it? So you will have code to display all the grades, correct? All the 5 or 6 or 7, whatever grades that you have. So you will have code to display all the 7 grades, but depending upon the marks, okay, you will, that particular code will be executed. Not all code will be executed, right? So for example, let me try to do this. So let's say you have steps to calculate average, sum, total, whatever, and then based on that, okay, you are creating this grade: A grade, B grade, C grade, D, E, F, or whatever. So these are the common steps where you are accepting the marks, calculating the sum, and calculating average. Okay, this is your common path. But after the grade, okay, or total, based on that, you will either choose this. Okay, so this. So here you see, okay, and then maybe let's say, later again you are combining all of them, and here. So this is a simple program where you have 1, 2, 3, 4, 5, 6 independent paths. This is what path means in testing. Okay, so when you test one application or just one value, it is not going to test all the, it's not going to test all the possible conditions. So that's called path. Okay, basically testing all the possible conditions is your path basically. So it's not going to test all the possible conditions. Okay, so that's what it says, that you are trying to test all the independent paths, all the possible conditions. Boundary condition means, if the value is more than 5, okay, do this. Now, so when you give 6, it should do this. If you give 4, it should do this. Okay, but the chances is that you might make mistake at 5. If I say more than 5, that means if you have 5, it should not do. If I say, equal to or more than 5, in that case it should do. So people tend to make mistake at the boundary conditions, isn't it? Okay, at when base. So you will have more chances of catching mistake if you give input value and 5 and see what is happening than 4 or 6. Okay, more likely. Okay, so that's why we focus on boundary conditions more than any other condition. Error handling. Okay, how do you handle error? So I'm saying enter 2 numbers, but you entered hello. Hello is not a number. A program, how does it handles invalid input, right? That's called error handling. So in unit testing, we test about the logic, the algorithms, the variables, okay? The interfaces. Interfaces means your software talking to another software, hardware, right? Independent paths, boundary conditions, and error handling. These are the things that we test in unit testing. Then integration testing. Why do we perform integration testing? It says that one module can have adverse impact on other module, right? So so that's why, as an independent module under a unit test, it might work fine. But when you club them together, they might impact one another. Okay, so that's why it is important to perform integration testing. Okay. So validation testing determines if the software meets all the requirements defined in the SRS. Having written requirements is essential. Regression testing is performed to determine, if the software still meets all of the requirements in light of changes and modifications to the software. Regression testing involves selectively repeating existing validation tests, not developing new tests. Okay, same thing that we have discussed, right? So it means it talks about requirements, and you match if the requirements have been developed or not, okay, or has been implemented, right? Developed or implemented or not. Okay, so here it says that regression testing, okay, okay, so let's say you had you have a version 10 released, okay, and you found an error. Now in version 11, again you will test for that problem. Okay, let's say in version 10 you found and you fixed it. Okay, it might reoccur in version 11. If it reoccurs in version 11, we say the regression testing has failed. So regression testing is about developing the old or existing tests. Okay, validation testing or normal testing, what we call, is about creating old and new both. Okay, but regression is mostly about, okay, old testing. You found it in the previous version and it got fixed. Okay, now it may not work in the new testing for some reason. Maybe the code could not move into the new version. Possible. You do not move the code to the new version. Okay, whatever be the reason, it can fail in the newer version, and that's why we talk about, okay, regression testing. So testing which has been captured previously, you want to rework on it and work with it. Okay. Alpha and beta testing, we already told you, right? It's better to provide customer with an outline of the things that you would like them to focus on and specific test scenarios for them to execute. So beta, right? Provide with customers who are actively involved with the commitment to fix defects that they discover. So when they discover, you tell them that, yeah, we will fix this in this version only, right? So this is about getting it tested. Acceptance testing, similar to validation testing, except the customers are present or directly involved. Usually tests are developed by the customer. Okay, they want to test it. Okay, now if you talk about different methods of testing, the first is called white box or glass box testing. White box or glass box. So a white box to glass box, when you pack something in glass box, you can see what is inside, isn't it? So when developers write the code, they know what is inside. So when developers test it, like integration testing or the unit testing, we call it as white box testing. Okay, being tested by someone who has developed, who knows. Okay, it means that who knows what is happening. Okay, so when you see an error, they will immediately know, oh, this error is because of this and this reason. Black box testing is testing done by those who do not know the working, do not know how the system is developed. Right, you're only bothered about input and output. Okay, this is the input I give. What is that what is the output that I'm expecting? Is it, is it valid output or not? Okay, so the validation testing, acceptance test, the validation testing, regression testing is like your black box testing. Top down and bottom up for performing incremental integration. Okay, so it is your integration. The top down means, okay, you add all and then you test, okay, one by one. Okay. Bottom up is when you, let's say if you have 20 different codes, right, 20 different developers, you don't integrate all, you integrate two first and run it and see, then third, then fourth, then fifth. Okay, so here if error is coming after adding fifth module, so you know that, okay, 1 to 4 is working fine, fifth is creating problem, right? So you know, it's the way you integrate it's up to you. Okay, the company might decide what is the best for a particular product. Second one is called act like a customer. Okay, here, you know, you will behave like a customer. Sometimes when you are booking a, say, flight ticket, right, by mistake we might enter email ID in our phone number field. Okay, so it will give you warning, okay, that email ID is invalid or phone number is invalid, right? So that's called error handling. It is possible, okay, that people might give wrong data. Okay, customers might give wrong data. For, you know, of course, nobody does it by intention, but it can be right when you are doing a lot of things. You might enter, okay, something in place of different field. So your software should be good enough to give that warning message and ask the user to re-enter, then getting crashed, you know, then taking the input and then crashing. So that's called act like a customer. So you're testing how would a customer test it. Okay, so that's the type, you know, the different level types of test. Any questions so far? All good?
Good, sir. Good, sir.
Okay. Then you have test types. Okay. So when you test, these are the things that a tester, whether it's a customer or QA or the developer, they focus on these things. Okay. First is called functional test. Okay. Functional test means I'm trying to add two numbers. So I entered 2 and 3. Is it give me 5 or not? That's called functionality. Okay. Adding data to the database. So when you enter a new data and say save, okay, you should be able to see in the database, right? That's a functionality, right? So functionality is all about the use cases, right? So you have written the use cases. So you execute and see, you know, your you know, the use case is implemented correctly or not. Algorithm is about the way you have implemented it. Okay. Now, algorithm is important, okay, because we want our product to work faster and more efficient. So better the algorithm, faster and better will be your process, isn't it? So output may be correct. Okay. If I have to add two numbers, I can add, you know, I'll add two numbers, add 10, add 5, then remove 10, remove 5, then add of 10, you know, remove 10, multiply by 10, divide by 10. I can do all these things. Okay, still I'll get the same value, right? I'm adding and removing, I'm multiplying, dividing by the same numbers, right? So I'm doing all those things, I will still get the same answer, right? But the process is bad. It's taking a lot more time to give you the answer than the first process. So that's what we talk about algorithm test. Okay, algorithmic test is the steps that you have followed. Okay, can it be improved? It might be correct, it's giving you correct result, but can it be improved? Can it be improved to work faster? Positive test, where you are inputting value, okay, for the system to work, right? Like for example, you enter name in name field, phone number in phone number field, email ID in email ID field, okay, and then you save to see whether it is working fine or not. Okay, that's called positive test. Okay, positive test means you are giving the values which are expected to see if it is working fine. Negative test is where your intention is to make error, right? Make mistake. You give yesterday's date to book a ticket, right? So, you know, so just to check if your system is booking the ticket or it's giving you sufficient warning that, you know, that data is invalid. As I said, you can enter text data in place of number, okay, to see if it is handling the error properly or not. That's called negative. Your intention is you want system to fail. Usability in terms of usage, how easy it is to use, right? So, so let's say you might invite our, some kids to test it. If it is developing a product for kids, right? Then you might have some kids to come and test it. Maybe you will have a camp in shopping mall or somewhere, and you want kids to come and try on it, right? So it's like to see whether, see, for us, maybe it's easy to understand. Okay, for example, let's say for developing a game for kids, and you use very high level English, right? Difficult words with longer spelling, right? So maybe for adult, it might look okay, but not for kids, right? For kids, you want to have shorter words, okay? Maybe 4 or 5 letters, not more than that. Sorry?
Simple terms.
Simple terms, exactly. Okay, so that's called usability. Okay, so maybe when you and I test it, we may not find it any odd, but when kids test it, they might find it odd, right? It may not, it may be difficult for them to use it. That's called usability. Boundary condition we discussed, right? That you're focusing on the boundary thing, like say, is that right? If your intention is like, if you say that, okay, if it is greater than equal to 70, you should get grade A, right? So greater than equal to 70. So of course 70. So the developer might have because see, you're talking about probability of catching the error, right? So if you enter 75 versus 70, there are more chances they'll catch error at 70. So you'll give 70 and see, okay, is it giving grade A or not? So 70 or more should get grade A, right? So in that case, when you see 70, you should get grade A. So, I mean, you can try with 75 and 70, but there are more chances of catching error if it is 70, right? So if you want to save time, you directly give 70 and see, okay? That's what we call it boundary condition. So when you read such thing, right, okay, more chances that we make mistake is at the boundary condition. Startup shutdown test. Okay, you start up and shut down to see if your product is not abruptly behaving, right? Data is saved properly, okay, or you're able to recover the data properly when shut down abruptly. So that's what we call it. You don't, mostly from the data perspective, that you don't want to lose any data. Okay, then platform test, running it on different platforms, different versions of Windows, Linux, different. So that's called platform test. Load and stress test. Okay, now this is again a very important test, actually very, really very important, because when you test generally, right, in lab, right, you'll have probably one user, okay, so you connect and you work like a customer, and you'll go through it. But when your application is in the market, right, you'll have many concurrent users or users logging at the same time. So if you talk about your banking software itself, right? Okay, in the lab, one person would have gone and tested all the features to make sure that you're able to do all the transactions, withdraw, send money, transfer money, pay bill, all those things. But when you deploy it, it's not a one person, right? Thousands of customers will be logging in at the same time. So in load and stress, what we do is we create, and there are tools to do that. Okay, there are tools which will create dummy loads. So in the backend, you can create, as if 1,000 customers are logged in. So in backend, they'll create that load like as if 1,000 customers are logged in, and there are tests. Okay, you have tools which will do that, and then you log in as 1,001st customer, and then you see if the slow, is it too slow or is it okay, acceptable? Definitely performance degrade will happen, right, when you have 1,000 plus users, but is it within the acceptable range? Or do you think there's a crash, application is crashing, cannot handle, so if you have, let's say generally you see 1,000 customers logging at any maximum time, let's say, okay, of course, at peak hours only you will have maximum customers logging in, right? So let's say in a day, okay, peak hour is in the evening and you have maybe 1,000 customers logging in. So now when you're deploying it, new model, you will test it for 3,000, 4,000, 5,000 customers, right? Because you don't want to change it every 6 months, 1 year. So you will, in the lab, you will create that dummy load for 5,000 users, 4,000 users, and see if your system is behaving properly or not. Okay, and stress is same thing. Okay, so you're putting stress on it. So maybe two, three people are working and trying to change the same data, let's say. So is your code handling that concurrency properly or not, right? So let's say if both are trying to change something, okay, and if my program has got access to it first, it should lock it, okay? You should not be able to modify when I'm modifying. When I'm done, then you can, right? Because two requests at the same time to make changes to our data will, will have negative impact, correct? So these are the, tests that you would perform, okay? So of course, when you get into QA role, they talk about these tests in detail, right? But as a BA, you should be aware of these terms. Okay. Finally, we talk about test planning. Okay, so how do you plan for a test? Okay, the QA, okay, they are getting involved in a project and they need to test it, right? So in that, there's a document called test document, and last slide is where I'll show you a picture of that. So it will have test plan, test procedure, and test report. Okay, plan is what you want to do, procedure is how you want to do, and what did you find is your test report. So test plan defines the scope of the work to be performed, right? Just like BA planning is about the scope, test, QA planning is also about the scope. Then procedure, a container document that holds all the individual tests. Okay, so you will write step by step, and this is done in parallel with software development is done, so that when software development is done, your procedure document is ready and you can start using the procedure document. Okay, so as you can read and understand, that procedure document can take a lot of time, right? Because it's talking about each individual test, how many tests you'll be doing, what kind of input you'll be providing, what kind of output you're expecting. So it does take a lot of time, it can take months. So this thing is done in parallel with your development, so that when development is done, even your test case is done and you can start executing it. Okay, and test report is what you present, okay, is what you present after tests are run. Okay, so test plan answers questions like how many tests are needed, how long will it take to develop those tests, how long will it take to execute those tests. Okay, you talk about test estimation, how long, okay, and what kind of output you are getting, test development and formal validation, validation readiness review and formal validation, test completion criteria. When do you say the test is completed, right? Okay, so so these are the things that you will put it in the estimation. All the use case information, right? So in the estimation, you will talk about the use case. Okay, so this test QA1 or QT1 is for FA1, right? QT2 is for FA1, QT3 is for FA5, right? So that's how you are linking each use case to each of the functional requirement. Okay. Okay, achieving some test coverage goal. What is coverage? Okay. Now, as I said, right, you'll have multiple paths, right? We discussed about multiple paths. So when you test it, right, you cannot test 100% of the code. One particular test cases might cover just 10% of the code, right? Your program could be thousands of lines of code, right? And when you start testing, you are testing each module, which could be a few hundred lines, right? So typically, your one test case might cover even less than a percentage of the code. Okay, I'm talking about the old, software where you have been developing it for years, right? So that's why we perform multiple tests, right? So that we are trying to test all the lines of code. Okay, but still, even if you perform 500 tests, it's likely that you are not testing some piece of lines of code. So coverage means when you are performing all the tests in the test plan, like a test plan, you will have 100 tests that you are going to conduct. So those 100 tests covers how many lines of code? Okay, 100 lines, 100% of the code is not possible, right? So maybe if you have 1000, the entire code will cover 900. That means your percentage is 90%, coverage is 90%. So coverage means all tests put together, how many lines of software code are you covering or are you testing? There will definitely be some lines of code which you cannot test it. Okay, so again 80-20 rule. So with 20% of effort you can test 80% of the code, but to test other 20 you have to spend 80% of effort, right? So you may not want to spend 80% of effort, so you'll probably spend few more and maybe do 90% of code coverage. Okay, achieving software reliability goal. What is reliability? Reliability means recovering from failure. Okay, when it fails, okay, first of all, it should not fail, right? So okay, your the error handling thing that we discussed should work fine, but even if it fails, you should be able to get it back without losing any data. That is also critical, right? You should not lose any data. Okay, so we talk about test complexity. It's better to have many small tests than a large ones. Okay, because see, most of the test cases these days are automated. Okay, you'll write few lines of code and it can perform all by itself. You don't have to involve the user, right? If you have to test 1,000 test cases, it is almost impossible for us to do it. It might take us more than a year to do that. So instead what you'll do is you will write a test case and you will run it. Okay, and when machine does it, it of course does much faster than what we can do manually. Right? So here you see this is one of the screenshot, you can say. Estimated number of tests 165. So we have 165 tests that has been identified as part of your test plan. Average test development time is 3.5 person hours per test. So what is the total person hours? 165 into 3.5. So you know that 577.5 hours of effort is required to conduct the entire test. Okay, so if you have one person, it might take 10 weeks. If you have 2 people, it might take only 5 weeks. 3 people means it might take just 3 weeks. So now that you know the estimation, you know how much effort it takes, you can plan as a team accordingly. Should you hire one person to do this test? Should you have 2 or 3, right? So so once you estimate it, this is part of estimation, right? Once you estimate it, okay, planning will tell you how many test cases. Okay, 165. Estimation will tell you on average how much time you take to test one. Okay. Okay. So see here, number of tested 165. Average test session is 1.5. So you have 247.5. But now 50% of them are regression testing. Okay. So half of 247 is 123. Okay, so total execution time is now 371, right? See, 247 is your new test cases, and regression is about 50% of that. So 247 plus 123 is 371. Okay? So you're saying that we need to have 371 hours of effort required to test it. Okay, so what is test procedure? Is collection of test script. Okay, so you'll be writing test scripts to test. Okay, and so procedure is about all the scripts. Okay, so is integral part of each test. Test project document should contain an unexecuted clean copy of every test, so that test may be easily reused. So see, when you when you create a test procedure with unused data, you can simply create a copy and test it whenever you want to, right? But if you don't create a clean copy, okay, you'll have to clean the output again before running it, right? When you run a test, you get some output. So when you cannot reuse the same thing, right? So that's why you have to write code as input, and when you are running it, create a copy of it, and then you run it. So when you run it, I'll show you what happens. Okay. you see here, you have, it says SPR, the bugs or the error is also called as SPR, software problem report. Okay, so SPR stands for software problem report, and it is about the bugs. Okay, how many SPRs means how many bugs, how many errors have you found? Okay, so test report is a completed copy of the test procedure. Okay, the procedure has script and the steps. So report is taking the procedure and adding the output or adding what you have seen there. Each copy of SPR will show the resolution. Okay, the problem that you have. Okay. Then it should also talk about open or unresolved SPR. Open means one that you created. Unresolved means something which is not available. Okay. So regression test executed for each software baseline. Okay, and SPR found in each baseline. Baseline is the we discussed this before as well. Baseline is the code. Okay, like when you merge the code, right? This is after integration. Okay, so after integration, every time you're doing integration, you will name it. Okay, so that you know which version have you tested. So baseline is the integrated code. Okay. Okay. This is how a test document looks like. So if you remove this red ink, red text, it is test procedure. Okay, so you take the test procedure, clean test procedure, create a copy, and you update with your finding. So I'll give you a minute to read and let me know what you see here. Okay, so with that, we end our discussion on QA. So yeah, any questions?